Hello everyone, welcome back to my channel. Today we are covering another very important topic, unit 6 of physics, which is electromagnetism. So let's start. The agenda for today is units, magnetism, electromagnetism, and lastly electromagnetic induction. Now the units that you need to be familiar are of current, which is ampere, potential difference, which is volt, and lastly power, which is watt. Then we have magnetism. Now for magnetism, you need to know that opposites like north and south pole or south to north pole, they attract, whereas like charges like two norths or two souths, they repel. Moreover, there are two types of magnetic materials. One is magnetically soft materials like iron, which are easy to magnetize and they easily lose their magnetism. They are basically temporary magnetized. Or magnetically hard material like steel, which are difficult to magnetize and they don't easily lose their magnetism. They are permanent magnets basically. Now we just covered permanent magnets, which are made up of magnetically hard material like steel, or electromagnets. Now electromagnets are made up of magnetically soft materials like iron, so they can be made magnet or a magnetic or non-magnetic. Magnetic materials include iron, steel, cobalt, nickel, all of these. All right, so next is steel is an alloy which contains iron, so it is also magnetic. And to test whether a material is magnetic, you should just hold it near a magnet and see. Next is permanent and induced magnets. Now there are two types of magnet, permanent and induced magnet. For permanent magnets, they are made up of magnetically hard materials like steel and they will produce their own magnetic field, so they don't lose their magnetism. Whereas induced magnet, they are made up of magnetically soft materials and they are temporarily turned into a magnet, like they magnetism is induced into them. They don't produce their own magnetic field. What happens is that one end of them becomes a north pole and the other becomes a south pole, and magnetic character is induced in them. But when the object is removed, when the permanent magnet is removed, their magnetism also removed, so they are temporarily magnetized. Next up we have magnetic field lines. Now magnetic field line basically is magnetic field is the region around a magnet where magnetism can be detected. And in a diagram we represent this magnetic field with magnetic field lines. The magnetic field lines, they should always point from north pole to south pole. They should never point from south to north, and they are used to represent the strength and the direction of the magnetic field. The distance between them shows distance between them shows the strength of the magnetic field, and the direction is shown by the arrows. Next up, when drawing, make sure to look at these points. Make sure to keep the spacing same, to keep the direction right from north to south, and remember to always grow from north to south and never touch or cross other lines. And magnetic field depends on the distance from the magnet. Next up we have uniform magnetic field. Now uniform magnetic field is comprised of straight parallel lines which are evenly spaced, as you can see in the diagram, and between two opposite charges like north to south, a uniform magnetic field is formed. So look at this diagram carefully. I think you should remember it, because you can be asked to draw a uniform magnetic field in the paper, as previous past papers have such questions. Next up we have the practical about investigating magnetic field pattern between two bar magnets. Now for this you need to place your bar magnet at the center of your page and draw around it. Then place your plotting compass at one end of the pole of the bar magnet. Then draw a dot to show there that the compass is pointing. Then move your compass to show that the opposite end of the needle is pointing towards the dot. Repeat these steps until you reach the other pole of the bar magnet. Then do this procedure at least 5 times from different points on the pole, and finally you'll have to join your dots to create the field lines. The diagrams at the right hand side, they are also important. They are showing magnetic field lines between a single bar magnet and between magnets, so make sure to remember these two. magnetic field lines between two like poles, like north to north or south to south, they repel. So the lines, magnetic field lines, they are moving away, as you can see in the diagram on the bottom right hand side. Next up we have current across a wire. Now current traveling along a wire produces a circular magnetic field along around the wire. The magnetic field direction can be determined using the right hand grip rule. Current is the movement of charged particles, so current produces a magnetic field. This magnetic field interacts with the permanent magnetic field to produce a force, and finally this force is perpendicular to the direction of the magnetic field. So you can be asked to draw this magnetic field too, so make sure to remember that it's a circular magnetic field. Next up we have magnetic field patterns of 3 different things. The first is wire, the next is solenoid, and then circular coil. So you need to remember these two. Next is electromagnet. Now in electromagnet there is a soft iron ore that is wrapped in a wire, and when current flows through the coil of wire it becomes magnetic. Next up is DC motors and loudspeakers. Now this is very important subtopic, and make sure to remember all of these points as it is, because a lot of questions have come in past papers of this, so make sure to remember it. Now for motor, current flows in the coil. This produces a magnetic field around the coil. This magnetic field interacts with the permanent magnetic field and produces a force which moves the coil. And finally the split ring commutator changes the direction of current every half turn as it splits, and this reverses the direction of the force, allowing the coil to continue spinning. For loudspeaker, instead of the normal DC current, alternating current from the source that passes through the coil in the speaker, and this produces a constantly changing magnetic field around the coil. This magnetic field interacts with the permanent magnetic field and produces a changing force. This causes the coil to vibrate in and out as the direction of the force changes, moving the cone, and the cone then vibrates, causes vibrations, which we hear as sound waves. So the main difference between loudspeaker and motors is that in motors there is DC current which is not changing direction, whereas in loudspeaker there is alternating current. Next is Fleming's left hand rule. So for this, the thumb shows the force, the first finger shows the magnetic field, and the second finger shows the current. So to determine the direction of the force of the magnetic field, you can use this rule. Next is factors affecting DC motor. Now there are 3 factors. The first one is speed of the coil, how fast it is rotating. Now you can increase the speed of the coil by increasing the strength of the magnetic field and the current. Next is the direction of the rotation of the coil. This can be increased by reversing the direction of the current and the magnetic field. And lastly, force supplied. Now you can increase this by increasing the current, the strength of the magnetic field, and the number of turns in the coil. Next up is electricity generation. Now electricity can be generated by rotating magnet or generator, which is rotating coil. So for rotating magnet, what you need to do is, first of all, magnet is rotated with the coil. As it turns, the coil cuts the constantly changing magnetic field line from the magnet. This induces a voltage in the coil. This can then be connected to an existing circuit, and finally in a generator, energy is being converted from kinetic energy into electrical energy. And to produce electricity from a generator, coil is rotated within a magnetic field. As it turns, the coil cuts the magnetic field lines. This induces a voltage in the coil, and finally this can be connected to an existing circuit. Next up is induced voltage. Now when a current cuts a changing magnetic field, voltage is induced, and you can increase induced voltage by increasing the number of turns in the coil, by increasing the speed at which it is spinning, and by increasing the strength of the magnetic field. Next up we have transformers. Now in transformers, alternating current is there in the primary coil, which produces a changing magnetic field around the primary coil, and then the iron core that channels the changing magnetic field from the primary coil through the secondary coil, and finally the changing magnetic field induces the voltage in the secondary coil. Now there are two type of transformers. The first is step up and the second is step down. Step up transformers increase the voltage. They add more turns in the secondary coil as compared to primary coil, whereas step down they decrease the voltage by adding more primary turns as compared to secondary turns. This is an example from your book to show how the questions regarding step up and step down transformers come. Now the question states a transformer has 100 turns on its primary coil and 500 turns on its secondary coil. If an alternating voltage of 2 voltage is supplied across the primary, what is the voltage across the secondary coil? So you can use this equation Vp divided by Vs is equal to Np divided by Ns, and you will calculate it. So this is all for this unit. Thank you so much for watching. If you have any questions, any suggestions, anything, please drop them down in the comment section below. Thank you. Take care.